All right, hello, Honors Geometry. Mr. Clark here. I hope you guys and your families are all healthy and happy, and we're able to get some toilet paper and all that good stuff. Um, obviously learning this way is a little bit different than what everybody's used to. But hopefully this video will help you guys get through the notes, and you guys can email any questions to my email. All right, so let's see. Before we get into this, just letting you guys know, I did the college geometry notes first, and I've never uploaded anything to YouTube before, so I ended up with kind of the skinny screen action. I did not turn my phone sideways, so kind of I guess you guys would call that a boomer moment, even though I'm technically an elder millennial. All right, so let's get into this. So we're talking about quadrilaterals here. We're going to start off with three special types of parallelograms. We've got rectangle, the rhombus, and the square. Just starting to focus on the rectangle. So on your first page, guys, some stuff that you could add into your diagram. A rectangle is a parallelogram, so the opposite sides are going to be congruent. So I'm throwing two tick marks on the top and bottom, one on the left and the right, and opposite sides are also parallel. We know that. So there's going to be two parallel marks on the top and bottom and one on the left and the right. Now, special parts of a rectangle compared to, your typical parallelogram. All four angles are going to be right. So we should have those drawn in. Now, all parallelograms have the diagonals bisect, but the diagonals of a rectangle are actually congruent. So you might notice that each little half of a diagonal, all four of them are going to be congruent to each other. Now, one thing I don't really have marked as clearly here is that we actually end up getting between the top and top and bottom triangles that you see here. They're actually going to be congruent to each other, and both of them are isosceles triangles. If we look at the marks here, so this angle right here is going to be congruent to that angle right there, and they're actually going to be congruent to this angle here and this angle here. So we end up getting four nice congruent angles out of that. Now, the opposite angles of the rectangle are not being bisected or anything, so we're going to actually get four more pairs of congruent angles that, unless it's a square, they won't be congruent to the other four that we just mentioned. Now, if you look at the triangles on the left and the right here, these two triangles are going to be congruent to each other, and they're both isosceles as well. Now, I'm not going to mark them, but we have vertical angles in the middle that would be congruent here, so that's something else that might help you along the way. But that's a quick little breakdown of how to mark up a rectangle diagram. Now, rhombus is a parallelogram with four congruent sides. So you might notice that it didn't have to use two tick marks on the sides because all four of them are the same. So we got one tick mark each there. Now the diagonals still bisect each other like any other parallelogram. So I have two tick marks here, two here, and then three here and three here. Now, different than the rectangle, the diagonals of a rhombus are not going to be congruent. So we have two tick marks each here and three here and here. Now, some special features of a rhombus. Yes, opposite angles are going to be congruent, and each diagonal is actually going to bisect a pair of opposite angles. So anytime you see a diagonal drawn into a rhombus, you're actually going to get four congruent angles out of that. So each side of the diagonal here, this whole angle's been bisected, so we get a pair of congruent angles right there, and they're actually congruent to these two, from the opposite angle across the way. Now we look, we have another diagonal going on here, and that diagonal is going to accomplish the same thing. It is bisecting opposite angles, so again we get, four angles that are going to be congruent out of that, two pairs. The last thing I didn't mention about rhombi, the diagonals are going to be perpendicular, so you got a right angle there. Now you really could draw in four different right angles, but I'm just going to put one there, and you can kind of reason out the rest by vertical angles and by linear pairs. That would be 90 degrees left here. All right, so looking at squares. Now, a square is a parallelogram that is both a rectangle and a rhombus. It has all the features of everything listed above and the parallelograms that we learned about, before this all started. So A square is a regular quadrilateral, which means, you know, all four sides are going to be congruent, all four angles are going to be congruent, and so forth. Now in a square, you might notice it has all the features I talked about above, and we actually can put a number to all these angles here, these bisected opposite angles. If they're all 90 and they get chopped in half, we're going to get 45-degree angles out of it. So each square, once you have the diagonals drawn in, is actually going to have 8 45-degree angles in it. And if we look at the triangles of a square, they're all 45, 45, 90. We end up getting, 4 total triangles that are going to be congruent to each other. So, we'll be able to use that on certain exercises. All right, so taking a look at page 2, we have the review of the properties of parallelograms, so hopefully you guys take a look at that. Now, rectangles, rhombi, and squares, they're all in that parallelogram family, so they're all going to have those properties. So I didn't bother, typing those out again for every single thing on the rest of the page. All of the shapes we talk about here are going to have that, until we get to the trapezoids and kites at the end of the packet. So properties of rectangles on top of the parallelogram properties, which, we have opposite sides parallel, opposite sides congruent, opposite angles congruent, the diagonals bisect each other. Consecutive angles are going to be supplementary. So on top of all that, when it comes to rectangles, we're going to have all 4 angles are right or congruent. The diagonals are going to be congruent in length. Now when we move over to rhombi, all 4 sides are congruent. So not just opposite sides, but all 4 of them. The diagonals are going to be perpendicular, so right angles in the middle. You're going to be able to use right triangles to your advantage on the exercises. And the diagonals bisect opposite angles, so we talked about that a little. Now, properties of squares. Squares have all properties listed, so they have all the properties of parallelograms, all the properties of rectangles, and all the properties of rhombi. All right, so page 3 here, we had some rectangle examples to look at. Sorry, showed the rhombus page, that's next. But anyways, so looking at the first one, we have UZ and ZS. This one, we could actually look at really any parallelogram because the diagonals are going to bisect each other. So UZ and ZS are going to be congruent. Set those equations equal to each other, and we get x equals 18. And then when we plug that back in to find US, the entire length, I ended up just plugging into UZ and then multiplying that by 2. So we end up getting 78 for that answer. Now, you could add the 2 equations together if you wanted. There's a few different ways you can get to that 78. The second one, we have RZ and ZS. Now, remember, the diagonals are congruent and they're bisecting each other. So RZ, SZ, TZ, UZ, all of those little diagonal halves are going to be equal to each other. So we can set the equations equal to each other. We'll get x equals 12. And then UZ is going to be the length of, any of those other 2. So just plug into either equation, and you're going to end up getting that, UZ is 44. The next one, we have RT and RZ. So RZ is half of that diagonal, so we have to multiply RZ by 2 to set it equal to RT. So when we solve it, we'll end up getting x equals 2. Then they want the measure of ZT. Now that's going to be the same as RZ, so just plug into that equation, and you should get 9 when you crunch that out. SUT, so SUT, we're talking about this angle right here, versus RUS, so we're talking about the angle that's adjacent to it. So we're dealing with these 2 angles right here. The vertex U is worth 90 degrees total, so we just have to add those 2 equations together and set them equal to 90. Solve for x, you'll end up getting 11. Now they want the measure of SUT at the end, so we plug the 11 into that, and you should get 39 for that answer. Looking at number 5, we have SRT versus UTR. So SRT, talking about that angle right there. UTR, it's going to be the alternate interior angle to that, so those 2 are going to be equal to each other. And we set them equal to each other and solve. Should get x equals 53. And then when we plug back into UTR, we should get 62 degrees for that. After that, to finish it off, we have RSU versus TUS. So again, that's another pair of alternate interior angles there. So we set them equal to each other. You get x equals 16, and then plug back into RSU to get 57. All right, at the bottom of the page, we have, we're given one angle. We're given that the measure of angle 1 is 37. Now, before we even start, what two angles are going to be congruent to angle 1 out of the numbers that we have listed in that diagram? So I'm going to pause for a sec. Been watching a lot of Sesame Street, and they usually give the kids time to answer. So 3 and 4 are actually going to be congruent to 1. So right away, I know that angle 1, angle 3, and angle 4 are all worth 37 degrees. So, that solves, number 8 and number 9 for us. Now, looking at number 7, when we're going after angle 2, well, if we look at angle 1 and angle 2, those make up vertex G here, or angle HGK. So that adds up to 90. So 90 minus 37 is going to give us 53 for angle 2. Now, once we have angle 2, remember, angle 2 is going to be congruent to at least one other angle here. So I'll give you a second to guess that. And it is going to be angle 5. So angle 2 and angle 5 are both 53 degrees. So you should have that. Now, the last two problems, we're going after the measure of angle 6. Now, remember, we know that 3 and 4 are worth 37. So we're going to add 37 plus the measure of angle 6. We're going to use that triangle to our advantage at all equals 180. When you solve that out, you should get the measure of angle 6 equals 106. Now, looking at angle 7, we can just work a linear pair from there. So if we know that angle 6 is 106, subtract that from 180, and we know that angle 7 is going to be worth 74. And of course, you could have used a triangle as well if you wanted to. There's a few different ways to come up with that 74. All right, jumping to the next page, page 4, we got some rhombus practice. So they tell us that SRT is 60 degrees. Now remember, that tells us that SPT is also going to be 60, because remember, the diagonals of a rhombus, they bisect opposite angles, and the opposite angles are congruent to each other. So based on that information, we have 60 here, 60 here, 60 here, and 60 here. So that's one way you could have went about solving this one. Now, if we're looking for the measure of angle RST, I looked at that, so RST, and I think I just previewed the wrong thing for you guys a second ago, so bear with me. But we're looking for RST. I'm going to call that X. I'm going to end up pulling out the triangle of STR to look at this one. So we have 60 here. The diagonals are perpendicular, so we're going to have a right angle right there for angle STR, and then we're trying to find RST. So there's a little diagram there that I separated. So we'll add that all together, and should get X equals 30 when you solve that out. Now, after that, they tell us that QTP, they give us an equation for that. Now, QTP, it happens at the intersection of those diagonals. They're perpendicular, so we have a 90-degree angle right there. Set the equation equal to 90 and solve. We're going to end up getting X equals 22 when you crunch that out. After that, we have PST. So PST is 29. They're looking for PQR. Now, remember, PQR is opposite from PSR, so those two angles are going to be congruent to each other. Now, if we know that half of PSR is, 29, we're going to multiply that by 2, and we'll end up getting 58 for that total. So PSR and PQR are both worth 58. Now, looking at, let's see, they give us PR is 8, so that's one diagonal. They give us SQ is 12, that's the other diagonal, and they want us to find PQ. Now, looking at PQ, it's part of this right triangle here, PTQ. So, knowing that the diagonals bisect each other, if PR is 8, that means that PT is going to be 4. And then if SQ is 12, that means that TQ is going to be 6. So we have 4, 6, and I've pulled out that right triangle to look at. We got 4, we got 6, we got a hypotenuse, and you can call that X. So we're going to be able to use the Pythagorean theorem. 6 squared plus 4 squared equals X squared. And we solve that out. We got the square. We got 52 equals X squared. We got to take the square root of each side, because remember, we're not looking for X squared. We're looking for X, and the square root cancels a square. So the square root of 52 should be about 7.2 when you round that. Now, looking at 14 at the bottom. Okay, so this is the one I thought I was previewing at the top of the page. A little memory lapse there. So FJH, this whole angle is 82 degrees. They want the measure of KHJ, so that's, just this angle right here. Now KHJ and KFJ are going to be worth the same. Remember, this diagonal is bisecting a pair of congruent opposite angles. So I'm thinking we take out triangle FHJ and we look at that. So we know that FJH is 82. I'm calling both of these angles x because they're worth the same and we don't know them yet. So 82 plus x equals 180. Solve that out. You're going to get 49 for x. So the measure of angle KHJ is going to be 49. Now looking at part B, they gave us GH and JH. Those are both sides of the rhombus. All four sides are congruent, so we're going to set those equal to each other. And x should be 2.75 when we solve that out. All right, jumping to page 5, some parallelograms practice here. So the first one, can we conclude that this is a rhombus, rectangle, or square? So the first one here, I noticed the pair of opposite sides are parallel, but that's every parallelogram. Now the important feature I noticed was we got 4 congruent angles here with FCE, DCE, and then DEC and FEC, 4 congruent angles total, 2 pairs, whatever, however you want to think of it. That tells us that the diagonals are bisecting opposite angles, so we do have a rhombus here. Looking at 16, I think the most common mistake on this one would be rectangle. I mean, it looks like a rectangle if we're judging a shape by its cover there. But remember, we need some sort of evidence. We can't always just trust our eyesight. So this is just a parallelogram because all we know is that opposite sides are parallel. We don't know anything else. We don't know that we have right angles here, even though it looks like it. We don't know that the diagonals are congruent, even though it looks like it. We need to see proof. So that's just a parallelogram. 17, we got a rhombus. Again, we got the opposite sides being parallel, and aside from that, we can see that the diagonals are perpendicular, so that's a rhombus. Looking at 18, they tell us that NP is congruent to OQ, so that means the diagonals are congruent, so we have a rectangle here, and again, they have the opposite sides being parallel, but that doesn't tell us anything extra. So the diagonals are congruent, we got a rectangle. Looking at page 6, we have the diagonal of that rhombus is going to be bisecting that angle there, so set the equations equal to each other, x equals 3. 20, it says rectangle, but this really could have been any parallelogram. The diagonals bisect, so set them equal to each other, x equals 12. Now 21 is the same exact diagram, but we're looking at, this says rhombus this time. Now remember, they're both parallelograms, so those diagonals are still being bisected, so x equals 12 yet again. Just set them equal to each other. Finally, we have a rectangle on 22. Now remember, the diagonals are congruent and they bisect each other, so all 4 congruent little diagonal halves are going to be equal. Set them equal to each other, x equals 3. All right, heading to the next page. This is just a review of, what we had on page 2. So hopefully you guys were able to fill that in. If not, just go ahead and double check page 2. Page 8, the answer for this is on page 9, so you're going to see it back to back, but that's what your chart should look like. Make sure you double check that. Page 9, same exact thing. So that was just to check your answers. All right, so now we're going to talk about proving parallelograms on the coordinate plane. So I'm going to do a part 2 video for that because this is going to be a little bit more talking, and I don't want to be sitting there for 3 hours while each video uploads. So I'll be right back with part 2.